Hello students, today we are going to discuss the properties of definite integral. In this section, we discuss some properties based on definite integral. So let us start. Property number is P naught. We denote the first property by P naught. In this property, we have integral a to b fx dx. This is equal to a to b ft dt. That means if we change the variable of integrand, then the value of the definite integral remains unchanged. That means the definite integral is variable invariant. Variable invariant means the value of the definite integral doesn't change if we change the variable in the definite integral. So let us now, we are going to prove this property. Consider, we denote the integral of this by the symbol I. Integral fx dx. Now consider the integral of fx as capital Fx. We consider the integral of this function as capital Fx plus c. Then we can write it fx plus c. And limits are a to b. Now if we put upper limit in this, we get fb plus c minus fa plus c. Now this c is cancelled out with this, so we get value of this as fb minus fa. The value of LHS is this. Consider this as LHS. Now taking RHS, which is a to b ft dt. Now again, the integral of ft from this can be written as capital Ft plus c, and we have to apply limit on these. Then this becomes fb plus c minus fa plus c. C is cancelled out with c. This is equal to fb minus fa. Fb minus fa, the value of RHS and the value of LHS. These values are same, that is, this is equal to this. Hence, LHS equal to RHS. This is the proof for this property. Now the next property is property P naught. In this property, we interchange the limit of definite integral, means lower limit is written as upper limit and upper limit is written in place of lower limit. Then the value of the definite integral becomes negative. The value of definite integral becomes negative, means sign of the definite integral changes. The proof of this is similar that we have done in previous property. LHS is taken as this, so value of LHS is Fp minus Fa. Now if we consider RHS, then RHS is minus b to a Ft dt. So here we write the limits are b to a, and there is negative sign before that. In this, first we put upper limit, then we get fa plus c minus we put lower limit, we get minus fb plus c. So this can be written as minus fa plus c, minus minus becomes plus, and this is fb plus c. This is minus c, because this sign minus plus becomes negative. C is cancelled out with c. This is equal to fb minus fa. This is equal to fb minus fa, and which is equal to our LHS. Thus LHS equal to RHS. This is the proof of this property. Now the next property, property P2. In this property, the integral is split in two integrals. One integral is a to c fx dx plus another integral is c to b fx dx, where c is a point in between a and b. C is a point in between a and b. So in this case, we can split this integral into two integrals. One integral has the limits a to c, and the second integral has the limits c to b. Now the proof of this can be done in similar manner as we did done in previous property. Taking LHS, a to b fx dx, and suppose that the integral of fx is capital Fx, a to b, we put these limits on this, then we get fb minus fa. Now if we take RHS, then this is a to c fx dx plus c to b fx dx, and consider the integral of fx as capital Fx, then we can write capital Fx and the limits are a to c. This is also written as capital Fx and the limits are c to b. Now applying limits on this function, so this becomes fc minus fa plus, and if we apply these limits, we get fb minus fc. Now fc minus and positive negative are cancelled out. This is equal to fb minus fa, and this is also the value of LHS. Thus LHS equal to RHS. This is the proof of this property. Now the next property is P3. Next property is P3. In this property, we have limits a to b f a plus b minus x dx. Here x is replaced by a plus b minus x. Then the value of definite integrals remains unchanged. Now for the proof, the value of LHS is evaluated as in previous property. Now we evaluate the value of RHS. RHS is a to b f a plus b minus x dx. we apply substitution in this. Let a plus b minus x equal to t, then derivative of these is 0 and the derivative of x is 1. So this becomes minus dx equal to dt or dx equal to minus dt. Now we change limits for the variable t. When x equal to a, the value of p is, we put a in place of x, so a cancelled out, we get b. And when x equal to b, we get value of b is a. So RHS becomes b to a ft and dx is written as minus dt. This is minus b to a ft dt. Now all of you know that by property number 1, the variable can be changed. So we can write b to a fx dx by p naught, by property p naught. Now we can interchange the limits. Then this can be written as a to b fx dx, then sign of this becomes positive by property p1, and this is equal to LHS. This is equal to LHS. Hence the property proved. It is clear, students? Now we are going to discuss another property, property P4. In this property, the limits are 0 to a, and here the integral is 0 to a f a minus x dx. This is the special kind of previous property, means it is a kind of property number P3. The proof of this can be done in similar manner. Here we take f, we take RHS of this, then f a minus x dx, a minus x is taken as t, then minus dx becomes dt, dx equal to minus dt. The limits are 0 to a. Now when x equal to 0, the value of t is a, and when x equal to a, the value of t becomes 0. So we can write here as a to 0, and ft dx is written as minus dt. So this becomes a to 0 ft dt, and now the variable of this can be changed by property p naught. So this can be written as a to 0 fx dx, and again if we interchange the limits, we get 0 to a fx dx, then the sign of integral becomes positive, and this is equal to LHS. This is the proof of this property. Now the next property is P5. In this property, there is 0 to 2a fx dx equal to 0 to a fx dx plus 0 to a f 2a minus x dx. This is property P5. Now we are going to discuss the proof of this. Let us consider LHS, which is 0 to 2a fx dx. There is a in between 0 and 2a, so we can split this integral into two integrals, 0 to a fx dx plus a to 2a fx dx, because a is lies between 0 and 2a, so we can split this integral into two integrals. One integral is from 0 to a and next is a to 2a. Now we get first part of RHS. Now we transform this into this form. So let x equal to 2a minus t in second integral. Then dx is equal to minus dt. We can change these limits for the variable t. When x equal to a, then the value of t is a. We put a in place of t, in place of a, sorry, x, we get the value of t is a, and when x equal to 2a, the value of t is 0. So this can be written as 0 to a fx dx plus at a we get a and this is 0 f 2a minus t minus dt. Then this can be written as 0 to a fx dx minus a to 0 f 2a minus x dx. Minus sign is written here, and we can change the variable of this by property P naught. Now we can interchange the limits. Then the sign of this integral changed from negative to positive. Then we get 0 to a fx dx plus 0 to a f 2a minus x dx. This is RHS. Hence proved. It is property number 5. Now there are two more properties. We are going to discuss property number 6. In this property, there are two statements. This was property number 5. The property number 6 is 0 to 2a fx dx equal to 0 if f 2a minus x equal to minus fx, and the value of this becomes twice of 0 to a fx dx if f 2a minus x equal to fx. This is property number 6, and the proof of this can be done with the help of property number 5. So we can write by property number 5 0 to 2a fx dx equal to 0 to a fx dx plus 0 to a f 2a minus x dx. Now if we write f 2a minus x equal to minus fx, then this becomes 0 to a fx dx, and we can write minus fx in place of this, so this becomes 0 to a fx dx. Now these are both are same integrals having one negative and one positive, so these are cancelled out and then we get 0. Now if f2a minus x equal to fx, then we write fx in place of this, then by 1 we can write twice 0 to a fx dx by 1, because both integrals becomes same, so on adding these two integrals we get twice of this integral. This is the proof of property number 6. Now we are going to discuss next property, property P7. In this property, the limits are minus a to a fx dx equal to we can write this is equal to twice of 0 to a fx dx if fx is even function. Even function means f minus x equal to fx, and the value of this becomes 0 if fx is odd function. If fx is odd function, that is f minus x equal to minus fx. This is property number 7. Now we are going to discuss the proof of this. We can write LHS, which is minus a to a fx dx, and this can be written as minus a to 0 fx dx plus 0 to a fx dx. Why it is so? It is so because 0 lies between minus a and a. This is minus a, 0 lies in between minus a and a. So we can split this integral into two integrals. One integral has the limits minus a to 0, and the next has the limit 0 to a. So this becomes these two integrals. Now we take x equal to minus t in first integral. In this integral, we write x equal to minus t, then dx equal to minus dt. We change the limits for the variable t. When x equal to 0, the value of t is 0. Sorry, x equal to minus a, the value of t becomes a. And when x equal to 0, the value of t is 0, so we can write it as this becomes a to 0 f minus t, and dx can be written as minus dt plus 0 to a fx dx. Now we interchange the limits. If we interchange limits, then this becomes 0 to a, or first we change the variable of this integral. Then we get a to 0 f minus x dx plus 0 to a fx dx. This is done by property number 1. Sorry, by property P naught. Now if we interchange the limits, then the value of this becomes positive. Sign of this integral changes from negative to positive. This is 0 to a f minus x dx plus 0 to a fx dx. Now we apply these two conditions on this case 1. If f minus x equal to fx, then LHS equal to, then the value of LHS is, this is written as fx, so twice of 0 to a fx dx, because when you put fx in place of minus fx, we get two integrals, both are same, so both when adding we get twice of this integral. In second case, when f minus x equal to minus fx, then value of LHS becomes 0, because these two integrals becomes having the same numerical value, but both are in opposite in sign. So both of these integrals cancelled out and we get 0. This is the proof of this property. For today it is sufficient, students. Now we will discuss the questions on these properties in the next video. Okay students, thank you.